Welcome to EDU World Space.
Faraway galaxies, if you look at the line spectra, will appear to be receding from our own galaxy at relativistic speeds. This is a cosmological redshift, and there are a couple ways that people have used to talk about this redshift. One way is to simply measure the shift in a wavelength and relate it using the relativistic Doppler effect equation. Okay, what that equation does is it relates the observed wavelength, and oftentimes it is one of the calcium K lines that they use from all these stars being emitted in the galaxy. But you relate that to the rest wavelength through the relativistic Doppler effect, where the V's are the speed of recession from us. And of course, those can be written in terms of the speed of light, V over C. Okay, that's sometimes called the beta factor. The other measurement parameter is something called the redshift parameter, sometimes called Z. It's a simple number related to the change in wavelength is lambda observed, which is much longer than the lambda at rest, over lambda at rest. Okay, that way you can kind of organize galaxies according to a simple parameter. So let's take an example. Let's say that we observe a faraway object and we see the wavelength in a particular line to be in the red. 656.8, that's almost the hydrogen alpha wavelength. That would be confusing. And we knew that the rest wavelength, because of where it occurs in the spectrum, we know which line we're looking at, should be 121.6 nanometers. Let's go ahead and find these two parameters. Let's call this equation 1 for the relativistic Doppler, and equation 2 for the Z parameter. The Z is pretty easy. That's just 656.8 minus 121.6 nanometer over 121.6 nanometer. And that turns out to give us over 4, which is a pretty high Z. You'll hear cosmologists who study faraway galaxies talk about high Z objects. Let's solve for the velocity with respect to the speed of light. So we have 656.8 over 121.6 squared is equal to 1 plus beta over 1 minus beta. And a lot of people use this fraction V over C as a beta. Don't want to call it gamma. And working that out, let's see. 29.17 times 1 minus beta equals 1 plus beta. Cross multiply, and you can get all the correct terms together. And And you'll see that beta is a substantial fraction of the speed of light. Okay, so again, an indicator that this is a high Z object.